What's up, y'all? In this video, we are going to look at some examples for natural logarithms. These examples are very similar to the examples that we did in our regular logarithms video, so if you want to compare and contrast the two, that's going to be linked in the description below. Let's get to it. All right, so we've got our natural logarithms here. We're just going to use the same properties like we've done in our other videos, and we're going to write these out. So here we've got the same logarithms with the base e, and we're adding them together. And all we're going to do is we are going to take ln, and we're going to multiply these two things together, so we get ln of 14. Again, if you've been watching my other videos, you're going to see that these answers are all going to be the same thing. The only difference is we've got ln here instead of some log. Over here, we wanted to make this thing equal to 1. One of the properties that we have to make this equal to 1 is when, if we have ln, again, I'm going to write base e of e, that equals 1. Because if we go to what a logarithm says this is the base, this is the exponent, this is the result. So e to the first power is going to be e. So this thing equals 1. So this is the same thing as this. So I could put ln of 2 plus ln of e. So now I'm going to just multiply these two things together, just like I multiplied these two things together over here. So I'm going to end up with ln of 2e. What if I want to write these things as a single logarithm or a rational number? Here we've got our power of a power rule. Up here we've seen that if we have a number out front here, that it goes up to the power there, right? This thing is the power, so it goes out to the front like we're showing here. So if we've got this example, let's start with this over here, then that just means that we've got ln base e of 6 squared, or this piece is ln of 36. And as I carry this other stuff down, ln of 18, now I'm going to have ln of 18 minus ln of 36. Our rules of this says if we are subtracting the logarithms with the same base, that we just divide these two pieces. So I'm going to be left with ln of 18 over 36, which is ln of 1/2, right? And finally, the last one that is similar to what we've done before, we talked about different ways that you don't want to just simplify by the ln's, that you cannot just divide these things straight away, that it's not the same as this because this whole logarithm is being divided by this whole logarithm, so it's not this result. But instead, what we're going to do is we are going to break this down into a base and a power. So we did ln of 3 cubed over ln of 3 squared, right? 3 squared is 9, 3 cubed is 27. So now I'm going to use this same power rule over here, and I'm going to bring this 3 out front and this 2 out front. So now I've got 3 ln of 3, that's being multiplied together, over 2 ln of 3. Now at this point I can say, since these things are being multiplied together and I don't know what ln of 3 is, then I could treat that like a variable. 3 times x over 2 times x, I can simplify those x's out. So I'm going to cancel these two things out. I'm going to simplify those down, and I'm left with 3/2. If you go back to the logarithm video, you're going to see that you have almost identical answers. All the work that I did here was the same as the work that I did in the previous video. So please do your best to try and not get freaked out just because you see a natural logarithm. That's the one thing that I want you to take away from this video. It's not that big a deal. I hope that was helpful. If it was, make sure you give me a thumbs up, and I will see you in the next video.